Welcome to this short video on atomic structure, which is for Physics Paper 1. First thing you need to know about is the structure of the atom. And the things you need to know are that in the centre of the atom is the nucleus. And this contains protons and neutrons. The protons are positively charged and the neutrons have no charge at all. Outside the nucleus you have these dotted lines here, which are the shells, and these are where the electrons are situated. I've shown 2 electrons here. The next thing you need to know is about isotopes. Isotopes are different versions of an atom, and I've used the example here of carbon. So normal everyday carbon has got 6 protons and 12 protons and neutrons. That's what those numbers mean. That's the mass number and that's the proton number. There is a version of carbon that's still carbon because it's got 6 protons, but it has an extra neutron. If you look there, the number there's 13, so there's 6 protons. There must be 7 neutrons in there. And so what we say about an isotope is it has the same number of protons but a different number of neutrons. Okay. The next thing you need to know about is the development of the scientific model of the atom. It started with a model that was thought up by J.J. Thomson. It's called the plum pudding model, and basically it was as though there was a small positively charged sphere, and dotted inside it were negatively charged electrons, a bit like the chocolate chips in a chocolate chip muffin. This was developed by Rutherford, who did an experiment involving some gold foil, which we'll talk about in a minute, and that led him to decide that the atom actually had a very small nucleus that was quite tiny, but was positively charged, and that electrons were somehow dotted around that in a cloud with a lot of empty space in between. Let's just have a quick look at Rutherford's experiment. So here you can see with my terrible drawing, here's the gold foil, which was extremely thin, and he had a device that could fire alpha particles, which are just very small nuclei with a positive charge, at the gold foil. And what he found was that 99.9% of them went straight through the gold foil, not by making a hole in it, but just because actually, when you're using things that are extremely small like alpha particles, the atoms that make up the gold foil have a lot of empty space in them. So the alpha particles just whiz through the empty space in between the nuclei of the gold foil. He also noticed that a few of these alpha particles were deflected, and the reason for that was they were hitting this tiny positively charged region at the centre, which he called the nucleus. The final development of the atom, or our model of the atom, was done by Niels Bohr, and he came up with the model that you're used to today, when he worked out that the electrons must sit in these shells at specific distances from the nucleus. The final bit of the puzzle was when Chadwick discovered neutrons, which also sat in the nucleus. The final thing to cover on this little video is about something called electron excitation. And what can happen is electromagnetic radiation, for example an X-ray or a gamma ray, a high energy ray, very like light but with more energy, might well collide with an electron and be absorbed by that electron in the atom. That electron becomes excited and it moves to a higher electron shell like that. But it can't stay there because that leaves a gap here. We can't have that gap. So it then drops back down again. But when it does that, it has to get rid of some energy. And what it does, it emits or gives out a photon of light. Okay, so that is in total the atomic structure information you need to have for your paper 1.